Hello, everyone, and welcome to this presentation. Our team was assigned to talk about random testing, which is using uniform or operational distribution. And yes, it is a great method to be able to test your system. It is cost effective, and we're going to be discussing a little bit what that implies. Here we go. As soon as I can move to the next slide. One sec. Okay, here we go. So random testing. Random testing is also known as a statistical testing. It's kind of like a input domain based and often black box method for software testing. There's two ingredients that are required for property-based testing. So you need a test data generator and a property sometimes called Oracle. For each test, the test data generator generates input to the program under test, and the property checks whether or not the observed behavior is acceptable. So for instance, there will be a sort of data generator that must be random. It cannot be like 1, 2, 3, 4. It has to be something random. And with that, there is attached to it, there is a property saying, is this input value acceptable or not acceptable? So with those two things, you can kind of gauge the level of your system to see if those tests are pass or a fail test, So random testing also continues to be reviewed as an advocate by some as a simple, practical, and cost-effective method to access software reliability. So again, it's a great way to figure out like the small or sometimes imperceptible mistakes or problems or even bugs in your system. And again, anybody can come up with a random testing because it's so practical, right? Just have it generate different random outputs and figure out a sort of quality assurance property, also known as Oracle, to be able to figure that out. Okay, so I want to give you guys a little bit of an example of a random testing, and that would be testing the function, right? We have there, if x is bigger than 0, return x, else return x. So with that, we also have the other function, the test ABS, with you will get a number and then goes through the for loop, generating x as a random number, and then the result being pushed to that function. So in other words, this is a simple way to test the random a random number, a random input to the system in order to figure out if really there are any mistakes in the output of the software. So what are some of the upsides of random testing? Well, one may believe and may think that it is achieving higher code coverage, or in other words, reaching more of the method blocks of code and lines of code. So really digging down and figuring out what really is going on with your code. And another one is that it can be very effective in Android crashing apps in an average of 85 seconds, according to our references. Also, apps can crash through stress testing, and it is only a matter of time to find out how long it takes to crash Android apps. So that's the cool thing about random testing, is that you can really go in and try to figure out, okay, how much can the system take? And this is a great way to do through random testing because it does bring a sort of processing management to create those tests and to run on your system. So bias testing can be avoided as an oracle or as a human simply has to run the programming, enter random inputs, and the results are pass or fail. So that's the interesting thing. If just a human goes in and puts in those numbers, that could be a way of randomly testing the system. And absolutely that oracle or that sort of property that will evaluate if the software is correct or not. This is definitely the most important part of random testing because then you can figure out if the tests are being successful or acceptable or not. So tests, this is a great upside that those random tests can be easily defined, and it's much easier to statistically find significance or interpret what the results of the tests mean, right? It's a much simpler way to conduct those tests. So let's go now to the downsides, right? What are some of the difficulties? What are some of the challenges that we face through random testing? Well, random testing will only find basic bugs. You're not going to go find incredibly difficult hidden bugs that will completely be difficult for your system. That's one, I guess, of the downside. It's because it's so simple, it must be done on finding basic bugs. And an effective oracle is seldom available, so you're going to have to put some creativity there. Another thing is that the creation of a comprehensive, accurate oracle often takes significant time and effort. So it is not that easy to set up a good property and a good value to evaluate if it is correct or not. And it also will not find all the same bugs as other methods would do, which are a little bit more, I guess, nitpicky about what goes into that system. Another thing is that due to the random nature of random testing, I'm sorry about that, something just fell. Due to the random nature of the testing system, when using a continuous integration, you can receive inconsistent results. So you kind of have to figure out what is the mean and what is the average, and is this really bringing good results to us? Another point is that the smaller the case of a failure, the more likely it would be missed. So also, since you are only finding the basic tests, it will be hard to find difficult tests, and most likely they would be missed by the system of random testing. And an example of this is the case of failure when, for instance, x equals 0, it would take about 4 million test cases to find that specific bug. So for instance, if your bug is quite specific and there's not much different properties that could achieve or come up with this problem in your system, it would take you millions and millions of trials in order to figure out what the bug is. Effectiveness, it depends, right? The effectiveness of random testing depends on the algorithm being used and the program that it is used on. But in general, it works to stress test as broad as possible with very little fine-tuning and a clear defined goals and procedures. It even may be useful in altered forms, right? So an example of that, and we put it on the slides, it is that random partition testing and dynamic random testing are really important concepts. So here are some references for you guys. I hope you understand that random testing is not the most powerful, most complete version of testing your software, but it is a great way to figure out basic bugs and maybe find out some things that you may have missed on. Thank you. My name is Mauricio, and I'm in the group with Jonathan, Jesse, and Chris. And this is our video for you guys. Thank you so much, and have a good night, day, week, whatever when you're watching this.